Hello, calculus students. Sorry I can't be with you today, but we still have notes. Yay, math. So, vertical asymptotes. That's section 1.5 here. Vertical asymptotes. X equals c is a vertical asymptote if the function goes to infinity or negative infinity as x approaches c. So what does that look like? Well, let's take a look at an example here. Here's our f of x. Okay. The limit as x approaches 1. So that would be our c. What happens as x approaches 1? Well, we know we have to come from both sides. So let's try. Let's try numbers really, really close here. What happens if I'm doing 1 over 1 minus 1.001 quantity squared? Well, that's going to be 1 over negative 0.001 squared, which is 1 over oh gosh. See here, that's tenths, hundredths, thousandths, tenths, hundredths, thousandths, 10,000s. I think that's right. Sorry. Anyway, there might be another 0 in there. Anyway, that is basically going to be 1 over 1 million. Tenths, hundredths, thousands, 10,000s, 100,000s. I think there's another 0 in there. 1 million. 1 divided by 1 over 1 million is just going to be 1 million. The smaller we make this number, that throw extra zeros in there, the bigger this is going to be right here. So here, x is going to be approaching, f of x is going to be approaching infinity, therefore as x approaches c, therefore c equals 1 is an asymptote. That's our asymptote. Even if we did 0.999, same sort of thing. 1 over 1 minus 0.999 quantity squared. It's going to be 1 over 0.001 squared. We square this. That's 1/1000th. It's going to become 1/1,000,000th. 1 over 1/1,000,000th. And it starts getting obscenely big. So how does this basically work? Whatever will make the denominator 0, as long as it's not creating a hole, that's going to be an asymptote. So let's do some examples here. If I start plugging in numbers really, really close to -3, that's going to make this become a number really, 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 really small on the bottom. Really, really close to 0, which is going to make this whole thing bigger than 0. Basically what we do is we say 5 times x plus 3. When would that equal 0? And that's going to happen, so when x is -3, so is a horizontal asymptote. I'm sorry, vertical asymptote. How do we deal with it here? well, let's see here. I'm going to factor the bottom. X squared plus 4x plus 3. When would that equal 0? Or another way to say it is this cannot equal 0. Therefore, x plus 3, x plus 1 cannot equal 0. Therefore, x cannot equal negative 3, x cannot equal negative 1. So, x equals 1, I'm sorry, negative 1, negative 3 are vertical asymptotes. Not too bad. Down here, same sort of thing. I'm going to be a little more careful in this one though, because I'm going to factor the top and the bottom. So the top is going to factor into x minus 1 times x minus 1. The bottom is going to factor into x plus 7, x minus 1. Now you'll see here that if I were to choose numbers just slightly bigger than 1 or slightly smaller than 1, it doesn't really matter. Those are going to be canceling out right there. Those are going to be canceling out. However, if I choose numbers and that's when we get a hole in the function. That would create a hole. Oh, man, I can't spell. Sorry, it's late at night. However, this one right here, if I plug in numbers really, really close to negative 7, like if I were to plug in negative 6.99999, and I'm going to go ahead and do it over here too. Man. These are essentially going to cancel each other out again. But right here, what's going to happen is that's going to be, negative 7.999 over 0.001. And the more 9s I put in, doesn't matter. I can make this smaller and smaller and smaller. 0, 0, 0, 0, 0, 0, 1. This number on bottom is going to get really, really close to 0. This is 1/10th, 100th, 1000th, 10,000th, 100,000th, millionth, 10 millionth. So negative, I'm going to say it's almost negative 8 up top. Negative 8 over 1/10 million. So if we multiply by the reciprocal, that's going to be negative 80 million. So we're definitely approaching negative infinity. Therefore, x equals negative 7 is a vertical asymptote. All right, moving on to the next page. So what's the limit of this? As I start choosing numbers close to 1 coming from the negative side though. So coming from the negative side, it's going to be 0.99999, things like that. So 0.9999 minus 1 and 0.9999 quantity squared minus 3 times 0.9999. Well, let's be honest. This is almost 1 here. 1 times negative 3. That's basically negative 3. This is going to be really, really close to 1 squared. So 1 minus 3. Something. Hang on. I just did a math set. I cannot say equals here. Shouldn't say that because these are not equivalent. However, the idea here being, if I'm just checking, this is going to be like 1 minus 3. That's going to be like negative 2 over 0.0001. Again, the more 9s I throw on here, that's still going to be getting close to negative 2, but this is going to be getting smaller and smaller and smaller, closer and closer to 0, which is going to make this whole thing much, much bigger. So this thing right here is going to be approaching negative infinity. Down here, approaching 3 from the positive side. So 3.01, that's going to be getting really, really close to 5. 3.000001. It's going to be like 9. Let's say square it, 9.000001 or 2.0001 or something like that. So, but then we're going to subtract 9 again, so it's going to be 5, something close to 5, and then something again really, 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 really small. As long as the closer this number gets to 0, the bigger this number gets. So once again, this is going to have a limit of infinity. Down here, write a limit for this function. Well, let's see here. What's going on here? What number are we getting much closer to? Looks like we're getting really close to negative 4. Okay. So it's going to be the limit as x approaches negative 4 for f of x. That's getting really big in the negative direction, so we're going to say it's equal to negative infinity. Yep, it's that easy. That's the answer. How can we write a limit to describe this asymptote? Well, let's see here. This one's 1, 2, 3, 4, positive 4. The limit as x approaches 4 for f of x, I didn't say it, but we'll call it f right there, is going to be infinity. Now hang on. It's got to be coming from both sides, right? This is actually only coming from the negative side. What about coming from the positive side? Well, coming from the positive side, I'm approaching negative infinity. So let's try it again. Limit as x approaches 4 from the positive side for f of x is equal to negative infinity. So we had 2 separate answers here. Or if we just wanted the limit as x approaches 4, either way it does not exist. But definitely wouldn't want to mislead people and say positive 4, negative 4. Okay, properties of limits. These are fairly intuitive, I think. If you got the limit as x approaches c for f of x is infinity, and the limit as x approaches c for g of x is some number. Doesn't matter what it is. Essentially, if as you go to infinity for this function, and then you're adding or subtracting some other number for it, it's almost like saying infinity plus 4 or infinity minus 4. We don't care. Even if it's infinity plus a million, it's still infinity, or infinity minus a billion. As you get to infinity, it doesn't matter how much you're subtracting. It's going to keep getting bigger. So that's just infinity. Well, if you're taking infinity times the limit, it's essentially just going to be infinity. Now, if this limit were negative, then yes, this is going to end up being negative infinity. Over here, if you've got some limit of, the limit would be L for this function, but if the numerator is going to some number, but the bottom is going towards infinity, well, that's kind of what we saw over here, isn't it? As the numerator is going towards some number, but the bottom's, if the bottom were going towards infinity, that's going to be going towards 0. Here, this is going towards 0, which made the limit infinity. This is kind of the opposite right there. So if it were like 2 over, some big number, this is going to be approximately 0. So that's the idea behind that one. And then if you have some constant times, if the limit of this is infinity, some constant times that, it's just going to be infinity, unless, of course, b is less than 0. Then the limit would be negative infinity. So you do need to keep that in mind. Okay, you do need to keep this in mind. If you're going towards some huge number and then you multiply it by a negative, it's going to be going towards negative infinity instead. All right, and the joke. So a math professor was very confused when a student gave the following answer on a test. The limit as x approaches 5 for 1 over x minus 5 quantity squared is equal to, the student wrote that. When asked why, the student said, "That's what you taught us. Here, I'll show you my notes." And the student got out their notes and showed the professor. The limit as x approaches 8 for 1 over x minus 8 squared is equal to, clearly, you wrote just 8 sideways. Yeah, it's that funny. All right. Thanks for watching, everybody. I should be back tomorrow. Vertical asymptotes. It's basically when the denominator would be 0 as long as it's not creating a hole. Again, plug in numbers really, really close to it and see what's happening. Okay? Properties. All right. Have a good one. Yay math. Bye.